So it's time to start talking about the radio frequencies. So in this scan, this is another victim scan. I'm going to show you the results of my scan. So this is the 447 megahertz band. Okay, that's pretty exact frequencies that are used. 75 dBm, big spike, taken by a nonlinear junction detector with a broad spectrum analyzer, using very specific protocols, scanning of the environment prior to the subject test's arrival, and then again afterwards, to ensure, as a double safety, that those frequencies are only present when the victim is in the room. So what do we know about this frequency band? We know that it's allocated and utilized by ham operators, but why is it inside of a human being's body? That means amateur ham operators who don't have the advanced stuff, could be used by, first responders. But this is an open access without security protocols. To my understanding, that means anyone can click into your body at any time, utilizing one of the semiconductors that have been stuck inside your body. And what are those semiconductors? We're going to explore them in a minute. So this is the statement by the expert that did the technical scan. The equipment I use is the same equipment that the FBI, CIA, and Homeland Security uses. The manufacturer is required to license it internationally as a weapon on espionage. I have in the past and still do work in various locations throughout the United States, but have to fill out a bunch of paperwork anytime I want to put it on a plane. I also know that if I want to take it into another country, I will have to fill out paperwork for not only the United States government, but for the country I'm taking it into. I have to get permission from their government, which I am sure would be another stack of forms and documents, and that I have to pay whatever fees that are required with the forms that I have to fill out and submit. The forms always ask, where will I be staying? Where will I be going? What will I be doing with the equipment? And who am I working for? And a bunch of other stuff. I would estimate that if I came to Canada, I would have to charge $5,000 a day plus travel expenses. I would suspect that I would have to be there for 2 or 3 days. Have I sent you the questionnaire? So that's to give you a good scope of the capabilities and the evidence. He is a courtroom expert also. So this is my results of my frequency inside Canada. Well, I'm inside Canada, and the frequencies are allocated inside Canada as well. So the previous victim had it at 75, and I'm at 72 dBm. It's a solid test, and I just read you the specs on the expert and gave you a little bit of background. So now let's go and look at what Grok has to say about 447 megahertz. Here we go. 447 megahertz. Tell me all the facts about this frequency and how it is used by ham operators, and what the security protocols are included in the citations for the frequency used in the United States and Canada. Frequency 447 megahertz falls within the 70 centimeter amateur radio band, which spans 420 megahertz to 450 megahertz in the United States and 430 megahertz to 450 megahertz in Canada. This band is part of the ultra-high frequency UHF range and is widely used by ham radio operators for a variety of purposes. Below, I'll outline the key factors about 447, its usage by ham operators, and relevant security protocols focusing on its applications in the United States and Canada. I'll also provide citations from authoritative sources. Facts. 447 is within the 70 centimeter band, a popular UHF allocation for amateur radio. The band is known for its line of sight propagation characteristics, making it ideal for local and regional communications. The wavelength of 447 is approximately 70 centimeters. There's some calculations. Propagation. As a UHF frequency, 447 typically falls for a line of sight path, with a range limited by terrain and obstacles. However, it can penetrate buildings better than high or frequency UHF or microwave frequencies. It's less prone to ionospheric propagation, like HF bands, but can occasionally benefit from the stratospheric ducting or sporadic E-layer enhancements, extending its range under specific atmospheric conditions. Power limits. In the United States, the maximum power output for amateur stations for the 77-meter band is 1,500 watts peak envelope power, unless otherwise restricted by geographical or operational constraints. In Canada, the maximum power is similarly high for advanced licenses up to 1,000 watts. Look at that, you can cook someone to death right from the inside out as an amateur ham operator. Isn't that cool? Okay, through the basic licenses are limited to 250 watts unless otherwise specified by Innovation, Science and Economic Development Canada, ISED. Geographical restrictions. In the United States, operations below 430, including near 447 megahertz when used wideband modes, are restricted near the Canadian border, line A restriction. So I guess all of us victims need to live right by a border security location in Canada side and the United States side to make sure they aren't segueing and bouncing around, right? Maybe that'll help. Canada does not allocate 420 and 430 to amateur use, so 447 falls safely within its 77-meter amateur band. Usage by ham operators is commonly used as a repeater output frequency in the United States. Look at that. Negative offset 452 megahertz, positive offset depending on regional conventions. For example, many U.S. regions use outputs of the allocated between 440 megahertz and 450 megahertz with inputs of 5 megahertz lower. So that range is within 5. All right. The band plan similarly designates the same. While the 446 megahertz is the national simplex calling frequency within the United States, 447 megahertz can be used for simplistic direct station to station. So I've got a station inside my body that goes to another station. And so does this other TI whose name is Susan. Okay? Modes of operation. Ham operators use 447 megahertz modulation, FM voice, digital modes, D-Star fusion, and occasionally amateur television, ATV or data links. Look at that. Applications, local communication, ideal for club nets, emergency communication, example, ARES, and portable operations due to its short range, high clarity characteristics. Repeaters extends range significantly, often covering 20 to 100 miles depending on antenna height and power. Satellite and experimental use. While less common at exactly 447 megahertz, the 70 centimeter band supports satellite uplinks, downlinks, and experimental modes. So you're uplinked and downlinked to satellite via communication by rented time on amateur satellites, satellites that rent time to amateur ham operators. So let's say they rent it on 50 satellites. That's a lot of power to access an open access 447 megahertz, which can ultimately kill a person if the device in their body is being accessed and utilized inappropriately. And there's no checks and balances for the abuse. There's no laws inside of Canada on the abuse of semiconductors. There's not even any guidelines. They won't even talk about them. Ironically, Mary Ann G. was cited in the Hogue report as being an unwitting participant in foreign interference. However, she also sits on the semiconductor board along with the former head or current head of science, innovation, and technology, and his name was Philippe Champagne, who's an elected member of parliament in Canada. And he's also a patent lawyer, including in biomedical research, and clearly, I believe, and suspect to do with semiconductors. And ironically, there are no laws, guidelines, or transparency or abuse investigations of the use of this because there's no laws on it. So it can be used by amateur ham operators, private military contractors, any U-Haul that will go and have a needle and can jab something into somebody, because this stuff can just be injected into a person with a needle. Not a big deal. Access granted. CT, CSS, DCS tones repeaters on 447 often use continuous tone coded squelch systems or digital coded squelch DCS tones to restrict access to authorized users. For example, a repeater might require 103.5 hertz tone to activate. So, yeah, that makes sense if you have something in your body and you could go a high pitch or a low pitch, and that's by your ear, would make sense, right? That's what was indicated by the technical scans also. So I have over 20 semiconductors in my body that were confirmed by this expert, and so does this other gal. Yeah. International mitigation. Operators must identify with their call signs every 10 minutes in the United States per 47 CFR to prevent unauthorized use, ensure accountability. Well, where is the accountability in Canada when they don't provide education, transparency, or policing for abuse and torture, utilizing uninformed consenting devices inside the human body? I guess they don't need it under a totalitarian government in a country that claims that, oh, we believe in supporting persons that are victims of crimes against humanity, but not our own citizens. We just will garbage their reports because we're utilizing them for science, innovation, and technology in non-consenting research projects. What does that totally amount to? Well, it means you're making money. Somebody's making money on a victim's body. And what does that mean? That means it's slavery. That means it's litigatable. All right, emergency and priority use. During emergencies, 447 can be prioritized for Rs and races operations within informal protocols to yield emergency traffic. I wonder what would be the emergency traffic inside of a person's spleen, heart, vagina, knees, rectum, base of their brain, or their ears. What kind of emergency operations would that look like? And what kind of tissue destruction and chemical poisoning would be in the body? Because a semiconductor inside the human body without informed consent is indeed a poison. Okay, citations. There's some citations. Wave pause satellites, Canada, blah, blah, blah. Conclusion. 447 megahertz is a versatile frequency in the 70 centimeter band, heavily utilized by ham operators in the United States and Canada for repeater and simple communications. Use is governed by FCC and ISED regulations, with security maintained through access tones, identification, and cooperative practices rather than encryption. So, like I said, it's open access. We'll just cooperate. Yeah, little Joey, little Frankie, and 65 other people can beam in to this satellite, and we'll have line of sight right into that environment, because we'll make sure that the line of sight is made available 24/7, because we can predict where a person is inside their environment. See that? For precise local usage, see specific repeaters on 447. Consult regional frequency coordinators or band plans, as conventions vary by area. So that concludes the 447. So here we go. We're going to look at the 447 megahertz. See who it's allocated to, upper, lower, who's using it, who's accessing it. There are 916 plus device authorizations with frequency operating ranges overlapping within the specified frequency range. There's also another really great database that the FCC offers. See if you want to start exploring that, that's great. But maybe it's time that we start contacting ham operations systems. Look at that. Quanzhou, Dong Dong, International, Po-Fung. Yeah, that sounds pretty American or Canadian, doesn't it? Po-Fung, Po-Fung. XIMN, Ratadel Electronics. XIMN. I think that's Chinese. This is all Chinese. Quang Electron Science and Technology. I guess they're, doing science, innovation, technology. Nanxing, that sounds pretty American. Hongying Electric, registered inside the United States. Irradio stations. eVote. Well, I've seen eVote a few times. Telco. Guangzhou Geosurvey Information Technology. Yep. A lot of these sound pretty Canadian or American, right? Lixing Communications, BTech. Shenzhen Yasar Technology. Look at that. So if you want to go and check this out, just go to fcc.io and you can check out the frequencies. Hope you like this cast. Sorry it was so long, and off we go.